Dear students, I welcome you all for this lecture series. So far, in the past lectures, we have seen how sensors and machine vision systems works in robotics in the industrial robotics course. And today we are here to see two applications. We'll see one by one. So what do you remember about this nuclear power plants, right? So immediately after I tell nuclear power plants, the flash comes in our mind is Hiroshima and Nagasaki, where in Japan, there was a nuclear explosion and a lot of people died, lost their lives. And there was a huge humankind destruction due to the hazardous radiation from these nuclear plants. So our industrial robotics, the fantastic application of these robots in this nuclear field or nuclear reactors will enhance human safety. So use of robotics and computerized nuclear tools in nuclear power plants has been identified as a highly recommended practice by IEA. It's an agency for human safety. The key rationale of robotics application has always been to avoid human exposure to hazardous environments and a task ranging from scrutiny and general maintenance to decontamination and post-accidental activities. To execute these activities, robots need to incorporate artificial intelligence, improved sensors capability, enhanced data fusion, and compliant human-like leg and hand structures for efficient motion. Next generation robotic systems in NPPs are expected to work in full autonomous mode in contrast to current semi-autonomous scenarios. So with this introduction, we'll see how this nuclear applications encompasses a wide range of uses, including power generation, medicine, research, and industrial purpose. So robots are increasingly being used in nuclear applications to perform tasks that are dangerous, difficult, and impossible for human accomplish. So what are the benefits we have of using robots in nuclear applications is increased safety. So what is an hazardous environment? The environment which is not suitable for human life, we call it as hazardous, where a human can lose his own life. So robots can perform tasks in such hazardous environment without putting humans' lives at risk. They can handle radioactive materials and perform inspections in the areas with high radiation levels. So improved efficiency, robots can work continuously without the need for break or rest, increasing productivity. So we normally have like when we start a reactor, it has to continuously generate electricity or it has to continuously propel some machines. It has to run continuously where the robots are highly expected to fulfill this kind of work of extended hours. So reduced human exposure to radiation is still, it is a miracle that it has happened so far after World War II. Still we have radiations in Japan. So by using robots, human workers can minimize their exposure to radiation, protecting their health and well-being. So case studies of robots in nuclear power plants, we have certain case studies here to see the impact on safety and efficiency in nuclear power plants. Remote inspection robots equipped with cameras and sensors are used in inspect areas that are difficult or dangerous for humans to access, such as radioactive zones and confined spaces. Radiation cleanup robots are employed for the decontamination of cleanup of radioactive materials, minimizing human exposure to radiations. Robots are utilized for maintenance and repair of equipment and infrastructure, reducing the need for human interventions in hazardous environment. So the emergency response and the various case studies have been done in lieu with the extent of usage of all these robots in nuclear power plants. So I hope you understood how these robots are used in nuclear application. We will see in the next lecture series with another application. Thank you all for your wonderful patient listening. Thank you.